Now we move on to the lab on probability. And to do most of the calculations, we need a package. And we're using the itertools package in Python, iter for iteration. So these are tools to facilitate iterations. The code shown here shows how you could calculate all the possible permutations of A, B, and C. So this was precisely the first example we talked about in class. So we've imported itertools, stored A, B, C as a list, and now we call itertools.permutations. So it requires just one argument in this setup, and the argument is this list of A, B, and C. So it figures out all the possible ways to order A, B, and C, where A starts, then you have B and C, and then C and B, then B starts, you have A, C, you have C, A, and C starts, you have A, B, B, and there are a total of how many possible outcomes? 6, right? And we figured out we can calculate the number of outcomes by multiplying 3, which is the number of options of filling the first position, by 2, number of options of filling the second position because the first position has been occupied, and then 1 for the number of ways you can fill the third position when the first 2 have been occupied. So it's 3 times 2 times 1, which is 6. And here we are converting the output from the itertools permutations function into a list, because the output is an iterator, and the iterator disappears once it's been used once. That's how it's been set up, so it's memory efficient. And then we have the result now as a list, and we can print each item in the list, and that gives us these line by line, right? Remember the syntax for the for loop. Each item, this can be any variable of your choosing in the list, and then you have the colon and you indent. Those are the two things, right? Column, and then you indent, and then you can print the items, and one after the other it prints all the possible outcomes. So the question is, what do you think this code will give you? Same kind of stuff, except instead of A, B, C, we go all the way to E. So the list is now longer. Same deal, right? Call the permutations function from itertools and provide your list, the list you want it to permutate. So it's going to give you all the possible permutations of A through E. We can get the length of the result, right? And that will be the total number of outcomes. And what do you think that will be? This is what we spent a lot of time discussing in class, right? It's how many items? 5. So it's 5 factorial. 5 times 4 times 3 times 2 times 1. And that's what you get from as the result length, and we can print it out. It tells you what they are, and last of all, we print each item in the list. So if you scroll all the way to the top, there are 120 permutations, which is 5 factorial. And then you go in here, for each item we print it. So it's A, B, C, D, E the first time, then it flips these two, and then it flips this one, and you have the list of 120 outcomes. How many ways can 3 lifeguards be chosen and ordered from a group of 5 people? I explained this example extensively, right? We are choosing and we are ordering. So we're choosing a smaller subset from a larger subset, and so it has to be 5 permutation 3. And how do you calculate that in Python? You use the itertools function permutations like before, but now you provide a second argument, which is the number of items you want to choose from. And so, the number of items you want to choose. So this is the total list of the names of the 5 lifeguards available. It's A through E. And then you provide that as a list here, and then the second argument is how many of them do you want to be chosen and ordered, and I want 3 of them. So this is 5 permutation 3, and you can get a length, right, from all. So this actually gets you the list of all possible permutations, and then we get the length of the list of all possible permutations, and that tells you the number of possible outcomes. And then the answer is printed out using this F print statement, formatted print statement, and it's 60 because it's precisely 5 times 4 times 3 factorial divided by 3 factorial, right? It's 5 factorial divided by 5 minus 3 factorial. So it's 5 factorial divided by 2 factorial, which is 5 times 4 times 3, and that is 60. Number of ways of choosing any 3 lifeguards from a group of 5. So this is a list of 5 lifeguards. How is this question different from this question? If you were in class or you've watched the videos, well, you know here we're choosing an ordering, so order matters, and we're looking at permutations whenever order matters. Here you're just choosing, we don't care about the ordering, so it's fewer, and then it's 5 combination 3 in this case. Here you're choosing an ordering, is 5 permutation 3. So we need to use the combination function in place of the permutation function, and this is the combination function. And so we're permuting what? These 5 items, combination, I should say combination. You're combining them, not doing permutations. So this is the list of 5 items, combination 3, and it does the calculation which we already talked about in class, and you get the length of the list as shown below. So I run it, and so at this point it prints out that the total number of, I shouldn't say permutations, total number of ways you can choose 3 lifeguards from 5. Let's change it. So total number of ways to choose 3 lifeguards from 5 is the length, which is 10, and that's just the equation I explained in class. So now we move on to store those outcomes, because this is a list of the outcomes. We want to store it as a data frame. So we import pandas as pd data frame equals pd.data frame. This, which is the key in the dictionary, is the header, the column header, and then result list will be any collection that contains any one-dimensional collection, and that in this case is all possible outcomes. So it's ABC representing the first 3 lifeguards, or ABD or ABE, and that's the 10 possible ways of choosing 3 lifeguards from 5, and the order is not important. So in combinations, ABC is basically same as BCA, because all the same 3 lifeguards are chosen. Now we move on to learn how to read and save CSV files. So you can read a CSV file directly into pandas using PD, which stands for pandas, right? Because we imported pandas as PD, read underscore CSV. How about saving data from your pandas data frame into a CSV file to CSV? What is a CSV file? It's basically comma separated data, and when you open it up, it looks just like Excel spreadsheets. So to underscore CSV to spit out a CSV file, read underscore CSV to read in the CSV file. So we already have this result, right, sitting in data frame called DF, where we can save it to a CSV file using the CSV to CSV function, and this is the name we're going to call the file. So it's going to create a file called outcomes.csv, and it will contain precisely this data in the spreadsheet. And then index equals false says don't store 0, 1, 2, 3 through 9, because those are the indices. So it just stores this data, because Excel already has indexing, right, which starts from 1 in Excel. So you can run this, and it's going to create a CSV file called outcomes.csv. Where is this outcomes.csv going to be located? Wherever this code is located. So in my case, my code is in my it's in this folder, and then it's going to be inside the same folder, because let me run it first. Yep, I've run it, and that will be the end of this video. I'll continue from here in the next.